So we look at problem E. We're trying to find the general antiderivative. This one looks a little bit more challenging. And so we're going to use a trigonometric substitution. These are four trig substitutions that you need to commit to memory. If you don't have them, you need to commit them to memory. Okay? Before you gasp again and roll your eyes at me and talk back, you have a sine squared plus cosine squared is 1. Jasmine, I'm guessing you already knew this one, didn't you? Yeah. 1 plus tangent squared is secant squared. You can generally remember those two. The last one is what people struggle with, but just flip tangent, flip secant, and you get that. Okay? I did provide this to you as well on a note sheet. It's sitting right here. This is the last time I'll give you this, but useful trigonometric substitutions. I took the 2 pages of formulas and I try to pare them down to just this little area here in terms of what you're going to need to know. Now, I'm not picking ones that I feel like, hey, I just want everybody to know that. I'm picking ones that I've actually used all these on the AP exam, okay, and on my test. So I built them into my test as well. So I would know these 4. So 3 over sine squared minus 1. What could I substitute for sine squared minus 1? Negative cosine squared. Well, what's negative cosine? What's 3 over negative cosine squared? Secant squared. Shoot, if I only knew what I take the derivative of to get secant squared. Tangent. So it looks like a really challenging integral, but it turns out to be a pretty easy integral. Next one looks really challenging as well. You got 3 sine of 2x over cosine of x. Here you got a double angle. Here you got a single angle. Yeah, if you simply just insert that, we've got the integral of a 6 sine of x cosine of x over cosine of x dx. You got the 3 here, you're going to multiply that by the 2. So the cosines go away. The integral of 6 sine of x dx, is it a positive 6 cosine or a negative 6 cosine? Negative 6 cosine of x plus a constant. If you don't put the plus constant, I take points off on the test. YouTube, I just had a student threaten to play the knockout game with me and punch me in the face. So, okay. Will not mention the name of the student. No. So anyway, I don't know how we teach, but all right. Try the next one. Okay. What's the difference between this problem and the problem we just did? It's bounded, and therefore, so this is a definite integral. The previous one is an indefinite integral. When you say a definite integral, you need to be able to come up with an evaluation, okay? So you're coming up with a number. Now, this looks a little bit more challenging. Somebody said last hour, they're like, well, now we're just doing what we did before. Sure, except you didn't have this problem. Okay, we're looking at 4 problems here that are a little bit more challenging integrals. We need to step up our game in terms of handling these integrals, because they're going to get a lot more challenging than what we see right here. Okay? So here's a little trick that you may not be familiar with. I'm going to rewrite this as the integral 1 to 2 of 1 minus x to the 1/3 divided by x to the 1/2 dx. And now I'm going to divide each term in the numerator by the term in the denominator. I get the integral 1 to 2 of 1 over x to the 1/2, or x to the negative 1/2, and then x to the 1/3 over x to the 1/2. What would I do to the exponents there? X to the negative 1/6. Jake is on fire. 1 over x to the 1/2 is x to the negative 1/2. And then if you do 1/3 minus 1/2, that's 2 over 6 minus 3 over 6 is equal to negative 1/6. So what's the antiderivative of x to the negative 1/2? X to the 1/2, or the square root of x, divided by, so multiplied by 2. Minus x to the, divided by 5/6, or multiplied by 6/5. And you're going to evaluate that at what? 2 and 1. Now, to save time today, we're not actually going to evaluate that. It comes out pretty messy, but you would plug that into your calculator. Okay. For the AP exam, they'll give you a lot of problems that you don't necessarily have to use your calculator for, like this one. Okay. I'm going to do the antiderivative. This is negative 3y to the negative 2. So as I take the antiderivative of 4y, what's the antiderivative of 4y? 2y squared. And then what's the antiderivative of negative 3y to the negative 2? Yep, plus 3 over y. I evaluate them, negative 1 and negative 3. I type in negative 1, and I get 2 minus 3 minus 18 minus 1. Or negative 1 minus 17 is negative 18. What does that mean about the graph? Yep, and it sits below the x-axis. Okay. Yeah, that's why it's negative. Because you have negative 3y to the negative 2. You're going to take the antiderivative of that, okay? And so you raise the exponent by 1, so it'll be y to the negative 1, and you divide by that negative 1. Okay, letter I. We're going to look at this integral. Is 1 plus sine squared anything special? It is not. So we're going to show you a trick. No. One minus sine squared is cosine squared. We start with that. Is there any way to get a positive sine squared and a positive 1 on the same side? No. I guess you could do this. You could do sine squared of theta plus 1. You could add a 1 to both sides. Well, so that would be equal to 2 minus cosine squared of theta. But it doesn't help us to put a 2 minus cosine squared of theta in there. So, but what I can do is this. I can divide each term in the numerator by each term in the denominator. And so now I have the integral 0 to pi over 4. What's 1 over sine squared? Cosecant squared. Sine squared over sine squared? D theta. What's the antiderivative of cosecant squared? Negative cotangent. What's the antiderivative of 1? Theta. What's the tangent of pi over 4? 1. So cotangent of pi over 4 is 1. You get a negative 1 plus pi over 4. And now we got to plug in 0. What's the tangent of 0? 0. So the cotangent of 0 is, wait a minute, shoot, we get an undefined result already? Why is that? Because if you look at the beginning, we could have caught it right away. Where is sine equal to 0? At, and you can't, right away from the beginning. Fundamental theorem calculus does not apply. Okay? But I did show you a nice tricky way of taking an antiderivative, didn't I? Which is why I took you through that process. But all right, last example. I'm setting you up to have success on this last one. You can do this. You can lead me through this. Signs cancel. Very good. The antiderivative cosine is sine of theta, and we're going to evaluate it pi over 3 and 6, or pi over 6. So on this part of the test, AP exam, you don't get a calculator, or on Mr. Gentz's class, we'll say. And so you got to know pi over 6, that's a 30-degree angle. Pi over 3, 60-degree angle. Question is, what are those terminal points? Somebody help me out. Root of 3 over 2. If you got to draw it out, then you got to draw it out. But it's best if you can just remember it. Is sine is the x value or the y value? Yes. So, is sine the x value or the y value? It's the y value. So I start with pi over 3. So I have the root of 3 over 2 minus 1/2. And I get root of 3 minus 1 over 2, exact value. That's a great AP exam type problem. A great Mr. Gentz test as well problem. Wink, wink. I know I really try to hide the content for my tests. I mean, the 8-page study guide is not exactly very transparent, is it? So, all right. You're welcome for the excellent lesson today. Get to work.